Hello, myself, I'm Jeepu Thomas. Here we're going to create a new EDK project for interfacing a DDR2 SDRAM with a peripheral, transferring a chunk of data from the DDR2 memory to the peripheral, doing some computation on the data that is transferred, and transfer back the data from peripheral to the DDR2 memory. Here's how we start a EDK project. I'm using the PLB bus here instead of AXI. Using Virtex 5 ML505 evaluation platform, for which I have to make some changes in order to suit it to the board that I'm using, which is a university board which contains Virtex 5 FPGA. I'm removing all the things that I don't require. I just require a DDR2 SDRAM, a UART, and the controllers for the memory to which the micro blaze processor will be writing data, and from which the instruction will be fetched, plus the UART or RS232 interface through which I'm displaying the result. So these are the essential things that I need, or essential peripherals or the controllers which I need, along with the micro blaze processor. Not using any instruction and data cache as of now. Moving forward, and thus I've created my hardware. Okay, so this is my hardware. It contains the LMB controllers for the memory, a microblaze processor, a block RAM for which it contains both instruction as well as data memory, a DDR2 SDRAM, a debug module, and two UART interfaces, a clock generator, and system reset module. I need to add some peripherals into it, or I need to create a new peripheral for this, and this is how I create a new peripheral. I'm using 2 logic memory spaces and 5 software registers, and I pretty much don't need any other extra things. I'm using burst line cache in order to improvise or increase the performance of the data transactions happening in and out of this particular peripheral, keeping the right buffer depth to the maximum extent possible, and data width is 32, through which the processor is actually communicating. Software registers, I'm keeping 5, and the memory spaces, I'll just keep 2. These are the default communication signals, and I need to create ISC and XST project files and the template driver files, which helps me write the application program in C, and thus it's finished creating the particular peripheral.